Welcome back for part 2 of my video recording, and hopefully it will just be a part 2. And I was just got finished with this kind of negative, PBL, project-based learning is challenging to implement. And I just wanted to pause in the middle and say that I have tried project-based learning. I did do a unit that ended up being quite long. It was longer than a month. But I had a project where my students made watersheds out of aluminum foil and then went through a series of investigations. So they used the project as a sort of learning. And it was very, very messy, quite literally and cluttery, and also with some food coloring and liquids all about. And it did involve quite a change from what I was used to, but I absolutely loved it. And I'm going to say a few more negative things about project-based learning, but let me tell you that it was so worth it. The relief that I felt like I was doing my job as a teacher so much better. A lot of the students responded very well to it. Just the energy in the room changed. And yes, there are new challenges with it, but if you're thinking about it, you're not sure. You might have to experiment a little bit, but I found it was a worthwhile experience, personally. So moving along, there are other challenging things about project-based learning. It can be tough for a teacher who is used to a traditional style of teaching to transition to a different form. So facilitating, it's a little tougher when you have to let the student lead with their line of inquiry, and your guidance is more so going along the lines of what the student is thinking, as opposed to you, the teacher, being in control of the time. So that can be a little bit of an adjustment. How do you assess? High stakes testing tends to test performance and facts. Some deep thinking is involved as well, but things like PBL are expected to garner in-depth learning, social learning, practical learning. So how do you assess that? Some teachers who have implemented PBL have fallen back on their older methods of teaching, and sometimes that really reverses the effects of project-based learning. And as I hinted at earlier, there are some special classroom management challenges that come about when you're teaching PBL. It is a messy classroom. Everything's kind of all over the place, but there is a way to do it, but it can be a little bit of a challenge. The mathematical struggle is real. A lot of math teachers feel pressure. There's quite a lack of information and research on PBL in math classes, and some believe it's because of the time. There's a lot of curriculum to cover. There's stress from testing. There's often this one right answer mentality, and the math standards can be feel like quite a bit. So this is a nice layout of how it might feel to teach project-based learning. The teacher, if you look carefully at this chart, and feel free to pause, the teacher is going to be more frustrated, it seems. A lot of their time is devoted to making this transition. But then the teacher by the end learns. And the students have some frustration at the beginning if they are not used to project-based learning. They don't know how to ask questions. They don't know how to lead. But then they seem to warm up to it a little bit faster. And I'm telling you from personal experience, I have seen students really warm up to it and come alive. So how do we make it work? Just kind of adhering to the recommendations and the layout that I gave in the part 1. Make sure it's real work, something that feels real and interesting to the students. Think carefully about the groupings. Don't want the groups to get too large. The assessments should be, kind of all over the place. Feedback is key to project-based learning, and touch on that again in a moment. It lends itself to STEM, so interdisciplinary. It's very social. It includes inquiry-based learning. I think that's a part of it that makes it work. And really bringing in people, things, actual stuff from the real world, and it kind of gives the projects a certain gravity. So here's an example. So let's walk through how this might look. This is a 3rd grade class. And I'm not going to show you the video. I'm just going to call out some images and highlights of it. So at the beginning, the teacher leads a discussion. And okay, you're going to be doing a project, students, and here it is. the students have an entry event to pique their interest, just to get them jazzed up about what they're going to do. So they use Minecraft, and they build a home for their family. Pretty impressive. Then they develop, and I think in this case the driving question actually came before the entry event, but they have this driving question: how do they design, plan, and build a home based on a real budget, location, and preferences of a client that they have to please? So the class has a discussion. What information is needed to answer this question? So the teacher is guiding the students to come up with a list of information. What details do you actually need? And she kind of helps them out here by giving them some themes, like, okay, what kind of cost information, what kind of size information, and just kind of doesn't do it for them, but kind of meets them halfway. So the students said things like, oh, well, how many rooms are in the house? What will it cost? What will the parts cost? How many square feet will it be? What do you want a garden? Do you want a garage? Do you want a fence? What do you want outside of the house? And in the discussion, they also talked about the entry event. So the students then actually interview outsiders who are brought into the class. So you can see in the picture here, this is an older lady, and they talk to real people, and they have this list of questions that they're asking. And then an engineer is brought in, a structural engineer, showed the students some real floor plans, had layouts of homes, and the students got their hands on some like legit blueprints, and they got really excited about it. Then after that, the teacher taught some lessons based on standards, writing, reading, and math. And she did a lot of stations. And everything the kids did, they did a lot of activities that seemed like, one-offs, but they were all tied into the project. So they were doing reading about building houses. Then they did another set of rotations based on math exercises. And each time in the rotation, there was at least one station where the teacher is a little more intensely teaching. Okay, this is how you get perimeter and area. And they did a fun unit where they used Cheez-Its to figure out square footage. Then the students, and you can see architectural symbols handout for the kids, and they started creating their floor plans, which were pretty impressive. And they're measuring around the room, and then they had a discussion and shared what they had created with each other. And there was a fishbowl style to it so that the discussion behavior could be modeled to the students. And they practiced how they were going to present to their clients, and then they presented to their clients. So the people came back in and they were showing them all their great work. They have their floor plan, and they had a really cool like three-dimensional house out of paper that they had made, and then they shared their costs and they talked about that. They had writings, they had their interest of the client. They actually speak to the client to share what they came up with in the interest of the client actually buying the house. So here are some strategies for teaching in math specifically that I was able to find. So it can be intimidating to do a project that takes a lot of time out of the classroom. So what about a project that might be able to hit several math standards at once? So here's some examples. So if a student's creating a rooftop garden, they might need to have components involving surface area and volume. And okay, now we have to add sprinklers. We have to work in the water, equations with circles and semicircles. Maybe if they're designing an aquarium, they're using measurements, volume, expressions, equations for the cost, and even involving measurements of temperature, water pH, so you can hit on a bunch of standards at once. Some more strategies. Don't feel pressure to do everything. It would probably, I don't know, I'm sure some teachers are pulling it off, but you don't have to have every single little thing that you want to teach the students be part of a project. You might want to mix it up if the students aren't used to it, so don't be afraid to do that. Where do you find sources, ideas? How do you do something as a project when you haven't before? Maybe the textbook material has a word problem in it and it could be transformed into a project somehow. Maybe the school has issues or something that could be addressed. Maybe the utensils used in the cafeteria, why aren't they made of metal so that they can be washed and save on waste being produced? Things like that. Maybe some math real-world experts can interact with the class. And teachers, you can I know this isn't true for elementary per se, because elementary teachers teach more subjects, but secondary teachers, collaborating with various content teachers, work up to big projects slowly. And this is something I think I'm going to change for next year, where, projects are in even smaller chunks or smaller projects, so students don't get too intimidated by those big projects. Math journals. I hear about a lot of math teachers at my school do this. They write about the math. They write about their math learning experience. And, apparently some math teachers dismiss that. But apparently it can be a really powerful experience and really help the students with their learning. And don't give up. Not everything's going to work. My project certainly didn't work perfectly. It's not going to. There's going to be things that need to be fixed, adjustments that need to be made. But maybe don't try one little thing, and if it doesn't work out, it doesn't necessarily mean that you can't make it work. I thought this was pretty interesting. We use the word math problem. Well, that's a problem, and we always think of it as this equation, a list of calculations, a list of computations to be solved. What if we changed the way we see this vocabulary word and turned the word problem into something else, turned it into more of that driving question? What if, here's your math problem, predict what would happen if the oil spill in the Gulf had not been stopped. Use this information to convince policymakers to make changes. So that's a problem. And it's something that has to be, as we learned with Wolfram, not just Wolfram, but Bowler was telling us to keep the math in context. Don't isolate and simplify the problem. Keep it in the context. I thought this was a pretty good piece of advice here as well. Don't try to force it. If you have a unit and you cannot figure out how to make it project-based, then don't do it. Just wait till a really good one comes along, because your instinct means that maybe it just won't work. And here are my list of references. It took up several slides here. And thanks for watching.